In today's video, we're going to be discussing specifically arithmetic sequences. We're going to talk about what it means to be an arithmetic sequence and how you develop a formula to then generate term for an arithmetic sequence. Let's get started. A sequence is defined to be arithmetic if the differences between consecutive terms are the same. So for our example here, we have 4, 9, 14, 19, and 24. To find the common difference, we're going to subtract any two consecutive terms. So we have 9 minus 4, which is 5. Or we have 14 minus 9, which is 5. We have 19 minus 14, which is 5. And finally, 24 minus 19, which is 5. Since our common difference is 5 every time, we can then say that this is an arithmetic sequence because we're adding the same number every time. And that's what we're looking for. We're looking for a pattern here where you're either adding or subtracting the same number every time. If we can identify that number, then we have an arithmetic sequence. If there isn't a consistent number every time, then it's not. For our first example here, we have a formula, a sub n is equal to 1 plus n minus 1 plus 4. We're going to find the first 5 terms of our sequence, and then we're going to identify if it's arithmetic or not. In order to find our first term, a sub 1, we're going to plug in a 1 for n, so we get 1 plus 1 minus 1, which is equal to 1. For our second term, a sub 2, we plug in a 2 for n, so we get 1 plus 2 minus 1, which is equal to 5. For our third term, a sub 3, we plug in a 3 for n, so 1 plus 3 minus 1 times 4, and we end up getting 9. For the fourth term, we have 1 plus 4 minus 1 times 4, which is 13. And then finally, for our fifth term, we have 1 plus 5 minus 1 times 4, which is 17. Okay, looking at our terms here, we now want to find the common difference. So what is 5 minus 1? It's 4. What is 9 minus 5? It's also 4. And then 13 minus 5 and 17 minus 13, each time we get 4. So our common difference is 4, and we can say that yes, it is arithmetic. Following 5 examples, I want you to go ahead and see if you can identify what the common difference is here, which means are we adding or subtracting by the same number every time. And if you can find a common difference, then state whether or not these are arithmetic or are not arithmetic sequences. So go ahead and identify your answers now. Identifying if something is arithmetic is equally as important as identifying the formula for an arithmetic sequence. So our formula is generated by saying a sub n is equal to d times n plus c. Now your book uses a different formula which uses u instead of a sub n. If you want to use the formula from the book, you're more than welcome to, but I'm going to focus on this formula here. So for our formula, d is going to be the common difference, which we have practiced finding, and then c is the difference between the first term and your common difference. So here we have an example. We have the terms 2, 8, 14, 20, and 26. The first thing we want to identify is our first term if we have it, and in this case our first term is 2. Once we know our first term, we then want to identify our common difference, and our common difference is again found by subtracting any two consecutive terms. So in this case, distance is 8 minus 2, which is 6. Once we know the first term and our difference, we can then find our c value, because c is going to be our first term minus the difference, which is negative 4. Finally, in order to plug things into our formula, we need to know d, which we have found, and we need to know c, which we have also found. So when you plug them in, you get your formula, which is a sub n is equal to 6n minus 4. Now that we know our formula, we should check it to make sure it works. And if I plug in, let's say, a 4, so my fourth term should equal 20, which means if I plug in a 4 for n, then I should get 20. Alright, 24 minus 4 is going to be 20. It checks out, our formula works. So now that we have our formula, we could use that to find any term within the sequence that we need, which is going to be very important in the next section where we're trying to find the sum of an arithmetic sequence. For our next example, again we're going to try and identify the formula for a sequence. We're told two pieces of information. We know the common difference is 4, and we know the first term is 15. Since we know the common difference is 4, and the first term is 15, we can automatically go ahead and identify c. So C is going to be, again, A1 minus D, which in this case gets us 11. Since I already know my common difference is 4, I can plug that in, and so my formula is then 4 times n plus 11. We're now asked to find the first 5 terms, which means I have to plug in 1, 2, 3, 4, and 5. When we plug in those numbers into our formula, again the 1, 2, 3, 4, and 5, we do get the 15, 19, 23, 27, and 31. Now we just want to verify a few things. Again, we're told the first term is 15, so we want to make sure that we do have a 15 for our first term. And we're also told that the common difference is 4, so by subtracting any 2 consecutive terms, we should get that as well. Alright, your turn. Here we're given the first term, it is 100, and the common difference is 3. I'd like for you to generate the formula for this arithmetic sequence. Go ahead and write down your correct answer. In this example, we're asked to find the formula, and we're not given explicitly any information. So looking at our sequence, we have 10, 5, 0, negative 5, and negative 10. We can assume that 10 is our first term, so now I know a sub 1. If I want to find the common difference, I can subtract any 2 consecutive terms. So in this case, let's say that I did 0 and 5. 0 minus 5 gets me my common difference, which is negative 5. And I could have used any 2 consecutive terms. Now that I know A1 and D, I can move forward to find my C value, which in this case is going to be 10 minus a negative 5. And I get a C value of 15. When I plug things into my formula, I now have a sub n is equal to negative 5 times n plus 15. And again, if you want to check this, I could check it for any of my terms. Let's say I want to find it for this term here, which is my 4th term. I would plug in a4 for n. So a sub 4 is equal to negative 5 times 4 plus 15, which is negative 20 plus 15, and that equals negative 5, which is what we wanted it to be. So we know our formula works. We are unfortunately not always given everything we need. Sometimes we have to search for information. So for our next example, we have 2 terms that aren't exactly next to each other. I have the 5th term, which is 190, and the 10th term, which is 115. So we have kind of a shortcut here to help us find our common difference. The common difference is going to equal a sub m minus a sub n over m minus n. And it doesn't matter what you label as m and n, the order could be switched. It just means you have a little bit more simplifying to do when you're done. I'm going to go ahead and do this in the order of things they've been given to me. So a sub m is going to be the 5th term, so I have 190, minus a sub n, which is my 10th term, and I'm dividing by 5 minus 10. So that's going to give me 75 divided by negative 5, which is going to equal negative 15. So I now know my common difference is negative 15. Knowing that my common difference is negative 15 allows me to go back and solve for what I'm missing, which in this case is my C value. So we're going to start with our general formula, which is a sub n is equal to d times n plus c. And we're going to pick one of our terms. Let's say choose the first term. When I plug things in, I have that a sub 5 is equal to d times n plus c, a sub 5, which means that 190 is equal to negative 15 times 5 plus c. When I solve things out, I have 190 is equal to negative 75 plus c, and by adding 75 to both sides, I get 265 is equal to c. So now I have my c value and my d value. I can write down my equation, which would be a sub n is equal to negative 15 times n plus 265. If I wanted to test that, I could test it for my other term, the one I didn't use. So we want to check and see, is a sub 10 going to work out if I plug in a 10 for n? Alright, so when we plug it in, we get negative 150 plus 265, and when you combine that, we end up getting that, yes, it's 115. So it works, which means that our formula is correct. Alright, we're going to go ahead and practice this one more time. So again, the first step when you have 2 terms that are kind of spread out here is to find the common difference. And to do that, we have our formula of d is equal to a sub m minus a sub n over m minus n. Now, if it wasn't clear from last example, a sub m and a sub n are the actual numbers. So I plug in the 26 and the 20 and the 42. M and N represent the position in the sequence that those numbers are. So when I plug things in here, I'm going to get 26 minus 42 divided by 8 minus 12. Again, one more time, the numbers on top are the actual numbers from our sequence. Your denominator are going to be the position within the sequence that those numbers are. As you go ahead and solve this, you get negative 16 divided by negative 4, which means that the common difference is going to be positive 4. And just to double check, that should make sense that it's a positive 4, because looking at our values, I have a 26 for the 8th term and a 42 for the 12th term, so our numbers are getting bigger, which means our common difference should be positive. Now we're going to use that common difference to help us find our specific formula. Okay, so again we know that our common difference is 4, and we're plugging things into our general formula. I'm going to go ahead and start with our first term again. So I have a sub 8 is equal to d times n plus c. We're going to plug in what we know. 26 is equal to 4 times 8 plus c. Again, when I'm plugging things in, I know my common difference is 4. I'm plugging in an 8 into n because it's the 8th term, and then the actual term itself is 26. So now I can go ahead and simplify things. We get 26 is equal to 32 plus c, and by subtracting 32 on both sides, I get that c is equal to negative 6. Which means for my formula, I have a sub n is equal to 4 times n minus 6. If I want to check that, I can use my other term. I'm going to check and see if I plug in a 12, do I get 42? So we have 4 times 12 minus 6, minus 6, which is 48 minus 6, and that does actually equal 42. Not 24. It equals 42. So it checked out when we plugged it in for a formula, which means that our answer is in fact a sub n equals 4 times n minus 6. Alright, now we have an application problem. We have a farmer who feeds his cattle every day in July. The first day he feeds them 97 tons. The second day he feeds them 94 tons, and the third day he feeds them 91 tons. Apparently his cattle are on a diet. So our question is, first off, find the common difference and interpret it. In order to do this, we're going to take two consecutive terms. So let's say we have 97 and 94. I'm going to subtract them. So we have our second term, which is 94, minus the first term, and that gives us a negative 3, which means that the farmer is feeding them 3 less tons of hay every day. We now want to find the amount of hay given on the 25th day, which means that we need to find our formula. So to find our formula, we know what our D is. We need to find C, which is again your first term, minus the difference, and I get 100. So for my formula then, a sub n is going to equal negative 3 times n plus 100. To figure out how much was fed on the 25th day, we plug in a 25 for n. And when we simplify everything, we get 25, because you have a negative 75 here, plus 100. So on the 25th day, the farmer fed the cattle 25 tons of hay. The last question is, how much hay is given out in the month of July? So what that means is we would have to calculate the amount of hay given out every day during the month. So we can start with our pattern. We know that we started with 97, and then we added 94, and then 91, and we would have to actually continue this out for 31 days for July. Fortunately, we're not going to answer this question today. We're going to answer it tomorrow when we talk about the sum of an arithmetic sequence. That concludes our lesson for today with arithmetic sequences. We're going to apply these ideas tomorrow of finding the common difference and finding the formula for an arithmetic sequence, and then using that formula to generate some terms. See you in class tomorrow.